Hello everyone, welcome to Dr. ND's Knowledge Hub. I am Dr. Naresh, and in this lecture series, we will learn Python programming from basics to advanced concepts in a simple and practical manner. Whether you are a B Pharmacy student, PharmD student, researcher, or simply curious about programming, this course is designed especially for you. So let's begin our exciting journey into the world of Python programming. Welcome to Lecture 1, Introduction to Python Programming. In this lecture series, we will learn Python from the ground up, starting with the basics and gradually moving to more practical concepts. Think of this line on the screen: import Python for beginners. Just as we import libraries in Python, today we are importing a new skill into our lives, a skill that powers modern technology and is increasingly transforming the pharmaceutical sciences. So let's begin our Python journey. You might think that Python is something only programmers use, but the truth is you already use Python every single day. When Instagram curates images and reels on your feed, Python is working behind the scenes. When YouTube recommends the next video you should watch, Python powered algorithms help make those suggestions. When Spotify creates personalized playlists just for you, and when Netflix manages its massive streaming infrastructure, Python plays a crucial role. So, even if you have never written a single line of code, you have already been interacting with Python unknowingly. And today, you will start learning the language behind these amazing techniques. Humans communicate with each other using languages like English, Hindi, or Telugu. When I say, please open the door, you immediately understand the meaning because our brains naturally understand human language. But computers are different. Computers understand only two things: ones and zeros, which we call binary language. So, how do we tell a computer what to do? That's where programming language comes in. Python acts as a bridge between human ideas and machine power. We write simple English like instructions in Python, and Python translates them into a form that computers can understand and execute. In other words, Python allows us to communicate with computers easily and efficiently. Python is the translator between humans and computers. One of the biggest reasons behind Python's popularity is its simplicity. Python is considered one of the easiest programming languages to read and understand. Let's look at this simple statement: print in the bracket head hello. Here, print is an instruction that tells the computer to display something on the screen. The parenthesis acts like a container that holds the information we want to display. And the word hello is the actual data or message we want the computer to show. When Python executes this line, the output is simply hello. Notice how easy it is to read. Even someone who has never programmed before can guess what this code does. And that's exactly what makes Python so powerful and beginner friendly. Every great technology has a story, and Python is no exception here. Python was created in the Netherlands by a programmer named Guido van Rossum. He released the first version of Python in 1991 with a simple vision: to create a programming language that is easy to read, easy to learn, and enjoyable to use. Over the years, Python continued to evolve and gained enormous popularity among programmers, researchers, engineers, and scientists around the world. Today, after more than 30 years of development, Python is one of the most trusted and widely used programming language on earth. And the amazing part is that its original philosophy remains the same: simple is better than complex. Here is an interesting fact that surprises many beginners. Despite its logo and name, Python has absolutely nothing to do with snakes. The creator of Python, Guido van Rossum, was a fan of a British comedy television series called Monty Python's Flying Circus. While creating the language, he wanted a name that was short, unique, and easy to remember. And that's how the programming language got the name Python. So the next time someone asks whether Python is named after a snake, you can confidently say, no, it's named after a comedy show. This is one of the most important slide because it answers the question, why should I learn Python? Python is not just a programming language. It is the engine powering the modern technology era. From web development, Python helps build and maintain the infrastructure behind many websites and online services that we use every day. In the field of artificial intelligence, Python has become the language of choice for creating intelligent systems, including tools like ChatGPT, Gemini, and many modern AI applications. Python is also widely used in data science and automation, where it can analyze massive amounts of data and automate repetitive tasks with just a few seconds on lines of code. This versatility is the reason millions of students, researchers, and professionals choose Python as their first programming language. And as you will see throughout this course, learning Python means learning a skill that is shaping the future. We have already seen that Python powers modern technology, but here is something even more exciting for us. Python is rapidly transforming the fields of pharmacy, healthcare, and biomedical research. In technology, Python is often called the king because it powers web applications, artificial intelligence, and data science. And in pharmacy, Python is increasingly becoming the future. Today, researchers use Python for drug discovery, molecular docking, bioinformatics, medical image analysis, machine learning, and clinical data analysis. So, by learning Python, you are not just learning to code, you are learning a tool that can help solve real world healthcare challenges and shape the future of medicine. Let's compare how things are done manually and how Python can transform the same tasks. In drug discovery, researchers often need to analyze thousands of chemical compounds. Doing this manually is extremely time consuming, but with Python, we can process massive data sets and identify promising compounds in minutes. In clinical trials, patient data is often incomplete or messy. Python helps clean the data automatically and reveal patterns that might otherwise go unnoticed. In drug discovery, instead of manually reading thousands of adverse drug reactions, Python can scan and analyze text to detect early safety signals. Even in pharmacokinetics, Python can generate precise graphs and models to better understand how drugs are absorbed, distributed, and metabolized, even eliminated. And it's not just for research. Python can automate everyday tasks also, from calculating BMI and doses to organizing spreadsheets and laboratory results. That's why Python is becoming an essential skill for the next generation of healthcare professionals. Here is a beautiful example of how Python is used in pharmaceutical sciences. This graph represents a typical pharmacokinetic profile, showing how the concentration of a drug changes in the blood over time. Notice how the drug concentration rises rapidly, reaches a maximum concentration, and then gradually decreases during the elimination phase. In pharmacology, creating and analyzing such graphs manually can be tedious and time consuming. But with Python libraries like Matplotlib, we can generate these graphs directly from raw experimental or clinical data in just a few lines of code. In fact, in Unit 5 of the B.Pharm first year syllabus, We will learn how to use Python to create exactly these kinds of scientific and clinical visualizations. So, Python doesn't just help us write programs, it helps us understand and communicate science more effectively. Now, students, let's imagine two pharmacists. The first is the traditional pharmacist. They spend a significant amount of time performing manual calculations, organizing spreadsheets, and handling large volumes of healthcare data using conventional methods. Now consider the Python empowered pharmacist. This professional combines pharmaceutical knowledge with the programming skills. They can automate routine laboratory workflows, analyze massive clinical data sets, integrate artificial intelligence into research, and uncover insights much faster than traditional approaches. The difference isn't intelligence, the difference is the tools they choose to use. As artificial intelligence and big data continue to transform healthcare, Python is becoming an invaluable skill. So remember, you are not just learning a programming language, you are future proofing your profession. So, what lies ahead in this Python journey? Here is your roadmap based on the B.Pharm first year, first semester syllabus. In Unit 1, we'll start with the fundamentals, variables, data types, input and output, the building blocks of every Python program. In Unit 2, we will learn logic using if else statements and functions, allowing us to make our programs think and make decisions. In Unit 3, we will explore data structures such as lists, dictionaries, tuples, and learn how to work with CSV files. In Unit 4, things become even more exciting as we use pandas to analyze real pharmacokinetic and clinical data sets. And finally, in Unit 5, we'll use Matplotlib to create beautiful scientific graphs and professional data sets for visualization. Step by step, we'll go from writing simple programs to solving real world pharmaceutical and healthcare problems using Python. Before we end this lecture, let me share three simple secrets to mastering Python. First, write it down. Don't just watch videos. Maintain your own notebook, write programs by hand, and make notes in your own words. Writing helps your brain understand concepts much better than passive reading. Second, devote time. You don't need to study for 6 hours a day. Just one focused hour daily is enough. Open your laptop, type the code yourself, make mistakes, and learn from them. The third one is build projects. Start small, create simple scripts, then gradually work on bigger projects. Every project builds confidence, and confidence is the key to becoming a good programmer. Remember, Python is not difficult, consistency is more important than intelligence. And if you stay consistent, I promise you will master this machine. Thank you for watching. I'll see you in the next lecture.